Give me a second. Alright, this is brilliant. I thought up until this moment, you couldn't even hear me. Which is a great way of getting started. Let's see. Yeah, of course you can't. Oh, brilliant. Alright, folks, at least better late than never. Better late than ever. It's a good thing you couldn't hear me because I didn't say anything useful. What did I say that's useful? Oh, come on. Oh man, it happened to me. It happened a couple of times already when I was giving talks at conferences and had to do some live debugging of weird issues. All right, it's better that it happened now than further down the road. What we're doing is we're solving Advent of Code. I solved the problems already, so this is not me solving them for the first time. I am prepared. That doesn't mean I'm not going to make mistakes or have bugs in my code. That will happen. It will probably happen more often the further we go down the road. There's 12 days of this. We'll be doing these sessions at 5 p.m. UTC every day. And the other thing I said, but you figured it out on your own, is that feel free to use the chat to ask questions, make comments, make suggestions, ask for different approaches, etc. Alright, without further ado, let's get started. Now, I thought about this for a second. I don't think it makes sense to read the problem out loud. What I'll do is give you the gist of it. So you get some input that looks like what you have on the screen, which will be a sequence of numbers prefixed by the letter L or the letter R. And these numbers, they're supposed to tell you how many clicks you're supposed to turn a small circular knob. And the idea is that you want to count how many times the dial ends up at 0. And because it's a circular dial, you have to somehow keep track of the times where the dial goes around. The problem also says that you start at position 50, so the dial starts pointing down. So this is the gist of the problem. What you need to do now is grab your input. So Advent of Code always gives you a text file as a puzzle. It always gives you your puzzle input as a text file. This is what mine looks like. It's a huge file. Yours will be equally long, but with different numbers. And once you download it, you can start solving. So let's do the following. Let me open a terminal window to use here. 2025. Now let me open VS Code. Let's do this as well. Okay, I don't care about the AI agents. And this is going to be our reference solution in case everything goes terribly wrong, but it shouldn't. So this is what we're solving now. So we're solving AOC day 1, given a circular dial and a number of instructions. Figure out how many times the dial stops at 0. So this is what we're doing. Now, when solving a problem, you can take the problem statement and you can try to break it up into smaller pieces to solve those instead of the bigger problem. The scale at which you want to do this depends on each person because difficulties are always subjective, but I'll try to do it here for this problem as well. So the different steps or the different smaller problems you need to solve are you need to take your input and parse it, right? Because what you have now is a text file and you need to turn it into something you can use. You need to be able to simulate a turn of the dial based on a number, which is the number you get from your input, and you need to make sure the dial works as a circular dial. So what they say in the examples is if you're at 10 and you do a left 20, then you should end up at 90 because the dial has 100 positions. I didn't say that explicitly, the dial has 100 positions. And because it's circular, if you cross the 0, you end up in the other side. But I mean, it's the same way your watch works. Your watch goes from 0 to 12, and you're used to it. After 11 p.m., it's midnight, and after midnight, it's 1 a.m. So the times go around, so does the circular dial. So let's start by taking the input and parsing it. Now, I like to do the parsing independently of whatever I need to do next. And it's a good idea to separate the parsing from the actual solving. And this applies for your other scripts as well, not just Advent of Code. So you do the parsing first, and then you do the processing later, so that it's easier to tweak each part. So what I'll do now is open the input file. I saved it here. It's this huge file with over 4,000 instructions. I'm going to open it in read mode. And now I want to create a list with all of the rotations. So what I'll do is I'll traverse the file, grabbing each line. So for each line in the file, I want to do something. I want to figure out if it's a left rotation or a right rotation. Distinguish left and right rotations. So the direction of the rotation is the first character of the line, and the magnitude, let's call it the magnitude, is whatever comes after. So line of 0 gives me the first character, which is going to be either L or R, uppercase, and then the number of, let's call them ticks, that the dial will do. And I want to separate the two, because now when saving the rotations, I want to do something. I want to save left rotations as negative numbers and positive rotations as positive numbers, because it's going to be easier to just add things and use a very useful mathematical operation to simulate the circular dial. So let's do each rotation will be a positive number if it's a right, or a negative number if it's a left or right. So now what I'll do is I'll take my list and I'll append. Now there's a couple of different ways of doing this. You can just check if the direction is left. You can do rotations.append the integer part of the magnitude, or convert magnitude to an integer and then make it a negative number. And then you do rotations.append int of magnitude. This works. Personally, I prefer something slightly different because I have inside the if and the else, the code is almost the same. I'm always appending, I'm always converting to an integer. What's changing is the sign. And to keep in line with the slightly mathematical theme of this problem, what you can do is write it like so. So you take rotations and you append, because this is the fundamental operation you want to do. You want to append to the list. The only thing that changes is the sign. So you can say it's going to be a negative number if the direction is left. Otherwise, it's going to be a positive number. And you multiply this with the magnitude. And now you don't need this if. Now, if this doesn't make sense, feel free to say something in the chat. Yeah, okay, so for left it's a negative number, and for right it's going to be a positive number. And when you're done, let's just print a couple of rotations to double check. Now let's run this. UV run. Actually, let's go into day 1. UV run solution. And these are the first numbers I get. Let's compare this with the input. So the first three should be 31, 49, minus 47, and that's exactly what I have. So this is my input parsing. So this is input parsing. Now let's solve part 1. So part 1 is count how many times the dial ends at 0 or stops at 0 after a turn. So if we want to count, you want to have a variable that does the counting, and you also want to keep track of the position of your dial, which starts at 50. Now what you do is you go through all of your rotations. You're going to take your position and you're going to add the value of that rotation, and then you need to figure out if you get a number that is too large or that is negative, because the dial only has positions 0 through 100, right? And in order to simulate this circular, the circular shape, and the fact that from 0 you can go to 99 and from 99 you can go to 0, you're going to use the modulo operation. So very quickly, let's see, can I open, let's do a quick diagram. So we have a dial, no, bad idea, we have a dial and the 0 is at the top. No, I don't want this to be filled. The 0 is at the top, and immediately to the left is the 99, right? And at the bottom is the 50. And what we're saying is that if you're for example in position 10, if you're in position 10 and you do minus 11, you're going to end up here in 99. But 10 minus 11 is minus 1, right? This is what you should get. But what we want to say is that this should match the 99. This is what we want to do. This should be 99. And the way you do this is by using the percent sign, which is the modulo operator. So by doing minus 1 modulo 100, this converts to the number 99. And you can see this in the terminal, for example. If you do minus 1 modulo 100, you get 99. So this module is going to be very important, and it's going to do all of the heavy lifting for our problem. Now let me know if this makes or doesn't make sense, because this is really the crux of the solution. Now let's open the code. So this is what we'll do. We're going to take our position. We're going to increase by the value of the rotation. And then we want to do the modulo 100 to make sure that we stay within the dial. So you can do modulo equals 100. And this is the same as doing position equals position modulo 100. So it's just augmented assignment. You can do it not only with the plus and the minus, but also with any other binary operator. So this works just fine. And then if the position is 0, you increment the count. And in the end, you just print. Oops, I didn't mean to go there, sorry. So this should be it. Run solution.py. 1023, this is what I get. And now, if I were solving this for the first time, I would copy this, I would open advent of code, and I would paste it. But since I solved it before, I can just double check, and the answer is 1023. So this is part 1. Now again, if you have any questions, if you have any doubts, just let me know. Otherwise, we can just keep going to part 2. And part 2 is similar. In Advent of Code, part 2 tends to be similar to part 1. It's just usually either a generalization or the same problem but with a bigger input or something like that, or just a slightly harder problem but within the same harder variation but within the same type of problem. And what part 2 says is that now you don't care only about when the dial stops at 0 after a turn, but you also care about every single time the dial goes over 0. So every single time it crosses the 0. And if we look at the diagram, in this example, you would count this situation once, because if you're at 10 and you go left 11, so this would be left 11. If you go left by 11 ticks, you're going to end up at 99, but you crossed 0. The dial was momentarily pointing to 0, so that would be accounted for in part 2, and you want to take that in mind. And the author is very nice here, so we don't forget. It might happen that you get something like L of 811. And this 800 means you're going around the dial 8 times. And in doing so, you're going to cross the 0 a bunch of times. So you need to take that into account also. They're very nice about it, and they say it in the problem statement. Don't forget about big numbers. So a way in which I think is reasonable to solve this problem is to break each turn into 2 pieces. First, you're going to take the hundreds or more, because the 800 here represents 8 full turns, and regardless of where you were, regardless of where you started, turning the dial 800 ticks means you're going to cross the 0 8 times, regardless of where you were. So we're going to split each turn into its hundreds, and we're going to take those into account. And then we simulate the smaller portion that is left. And when we do that, we just check if we cross the 0. And then we also need to make sure that we need to check if we landed at 0. So this is a way to solve this problem for part 2. What does this look like in code? Let's see. Let's do part 2 here. And I see some folks in the chat that already solved this, so I'm curious to know if you did it in a similar way or if you did something different. So for part 2, we're still counting, and we're still keeping track of our position, which starts at 50 still. And now we go through each rotation, and now we do the splitting. So the full turns, what you want to do is kind of take the value and do the floor division by 100. This works well, for example, if you do UV run Python and then do 811 divided by 100, that gives you 8, which is the 8 full turns. Someone in the chat says they did it in a similar but uglier way. Well, if it works, it works. But the problem with the floor division is that if you have a negative number, for example, the left 811 should be minus 811. If you do floor division here, you get minus 9, because it's rounding down. So this isn't perfect, but what you can do is you can just do the regular division, and then you can get the integer part of the result. And this will do no rounding, it just gives you the integer part. So you can get the full turns by doing this, and your counter is supposed to increase by the total number of full turns. but it's the absolute value because we need to be careful not to subtract counts. So this gives you the full turns. And now the rest is, so you take the rotation and you're going to subtract the number of turns you already did. So we already did these many full turns. And in case you're wondering, what if the full turns, shouldn't this be the absolute value of full turns? What if full turns is negative because of this case? Well, even if it's negative, this works out just great, because if you do, let's simulate this. So let's do, the rotation was minus 811. And now you get the full turns is the integer part of this division. Let's maybe move this away from the edge of the screen. The full turns is the division, so this should be minus 8 at this point. And if you do rotation minus 100 times the full turns, the minus of the full turns cancels out with a minus from the subtraction, and you actually get just a minus 11. So this really is the minus equals is the operation you want. Very convenient. So this is what's left after the full turns. Great. So now, if you have no rotation, then you can just skip. Actually, to be fair, I'm not entirely sure this is needed. We'll reason about it in a second. But if there's nothing left, so if this was a whole number of turns, period, you just skip. Otherwise, what you do is you compute your new position, which is going to be wherever you were, plus the rotation. And now you're going to check if your new position... yeah, okay, so now what you do... what you do now, and I have a second variable because I need to be able to compare where I was with where I am, you need to check if you cross the zero. So one of two things happens, the situations that are of interest. Either you were close to zero and rotation is negative, and now new position is negative, and that means you crossed from the right to the left, or position was close to 99, rotation is positive, and now new position is greater than 100, which means you crossed to the right. And I might have negative numbers here or numbers greater than 100 because I haven't taken the modulo yet, so I haven't used the percent sign yet, and that's the point. So not taking the modulo yet allows me to compare where I was with where I am and making sure, or making it easier to check if I crossed. So if the position was positive and my new position is smaller than or equal to 0, this is one case, or, and this is not going to fit in a line, so let's do this, or my position was wait, give me a second. My position is always, oh no, I was thinking, do I need this? Because here I can just check if my new position is greater than or equal to 100, because my starting point was never 100 or more. I always start between 0 and 99, so I don't need to check if my position is positive, because it always is. But here I need to check if it is strictly positive. Otherwise, I might be miscounting when I end in a negative place but started at 0. Is that it? I think so. We'll see. I think that's it. So in these two cases we crossed, which means we count, and then we update the position to be the new position modulo 100. And in the end we print the count. And if I run this, let's run 5899, and if I double check with advent of code, okay, for my input it was 5899. All right, so this is correct. Now what I was wondering, do I need, I'm pretty sure I need this check. So it's not enough to check that I'm, or is it? It might be enough to do this. No, it's not enough. All right, so as you can see, by removing that other check, I have a much larger number of, my count is much larger, and that's because I'm, but can I fix it? Wait, give me, because I'm not sure. Can I fix it with this? No. Okay, it's still wrong. Now it's much closer, but I'm off by 1. All right, so we do need this check. Okay, and is this, yes, this is correct now. All right, and this solves part 2 in a, I think it's a reasonable piece of code. I mean, it takes up too much vertical space because of the font size and the comments, but it feels pretty decent. Let's see if you have any questions or any thoughts. Feel free to share. Otherwise, what I'll do is maybe with a lot more if clauses, right? I try to avoid if clauses. Well, not necessarily, but I wanted to do this. Maybe you're thinking of something like the full turns, or when there's numbers involved, I tend to try to do calculations that I can use instead of using ifs to check whether I should do something. I'm not sure if that's what you were specifically talking about, but it's what I like to do, at least for my own code. Now, if there are no other random comments, but you can share them later, I'll also share a quick thought, which is no, I'm not sure if no, let's not go there. Yeah, parsing into negative positive would have helped already reducing the ifs. Yeah, when parsing, I did the wait, what? Yes, I have if direction equals I'm not sure I follow NJ. But the parsing, breaking the L and the R into positive or negative, it's just because I was already primed for thinking about the modulo. But one thing that would make sense either way, even if you didn't turn it into a negative or a positive, would be to parse the rotations into a tuple and make it into a tuple and make it the first number be the first position be the L or the R, and the second position be the number, even if you didn't make it negative or positive, because then you're separating the two pieces of information that you care about, which is the direction of the turn and the magnitude, which is what you have here. And for me, I already knew I could bake the information into the number, which is something common, left and right being negative or positive. But yeah, even if you didn't make it negative or positive, you could easily turn these into tuples and also already be in a better position for parts 1 and 2. And I see, yeah, I got confused trying to fit solution, the first solution for the second part. Yeah, it also happens. There's plenty of times where part 2 can be solved by tweaking part 1 slightly. Usually it takes a bit to figure out what the correct slightly here is, but it's not always the case, and sometimes it's just easier to redo the whole thing. Now, can you explain if not rotations continue? Which should be this part. I can, but first let me check if I really need this, because I don't think I do. Yeah, I don't. because like I said in the beginning, I think you didn't have, I was muted when I said it, so maybe you didn't. Yeah, I think I was muted when I said it, but I took slightly longer to solve this than I am proud to admit, and by slightly longer I mean a bit longer, because I was confused. I was trying to do the check of whether I crossed the dial, the zero, in a different way, and it was, well, clearly not working for me. And one thing that was not working at that moment was the fact that I was double counting times where you stayed at 0. But because this condition is now decent and it's properly done, you don't need this. So yes, I can explain, and my explanation is I'll delete it because I don't actually need it. Alright, any more questions or comments about this? Otherwise, I have an idea for something that could be fun, although I'm not sure I'll have enough time. Yeah, exactly. Rotations that already start at 0, you have to be careful not to mess them up. I was thinking... Let me know what you think. I was thinking of trying to create a small visualization of the dial with maybe Pygame, because it's the thing that I know best, with just the circle and the pointer of the dial rotating left and right, and the counter going up as you cross the 0. Would that be fun? I don't have a lot of time. I have 25 minutes before I go into a different session, but I think it could be fun. Let me know if you're up for it. Alright. I like the... Yeah, let's try. It feels like when my personal trainer says, come on, let's do this, but then it's just me doing it. But yeah, we can try. Let's do a visualization here. Dial.py, and let's move it into the correct folder. Alright, now what do I need? I'll use Pygame because it's really the only thing I know. So uv add Pygame. Let's add Pygame as a dependency to this script. Nope, what did I do wrong? I'm in the wrong folder. Now we run it again. Alright. Now from pygame.locals import everything. Don't do this. Don't import star. From pygame locals we import everything. Let's do width of the visualization and the height. You know, the screen. Pygame.display .set mode width height. Now a couple of colors. Let's do black and white for starters. Alright, screen. Now let's do screen.fill black, screen.flip, and let's run the Pygame event loop so that my application does not hang. So for event in pygame.event.get, if the event type is the quit type, I want to quit Pygame and I want to exit. If not, there's nothing to do. Let's see if this runs. uv run dial.py. And where does it... Did it open or did it... What's going on? Pygame usually takes a while to load. Object has no... Right, this is not what I want to do. I want to do... My bad. Pygame.display.flip. That's how you update the screen. And I have a black window that's 600 by 600. Alright, we're off to a great start, and I can close the window. So we are starting well. Great. So now what we'll do is... What do we do? We want to draw the... Let's just do a simple circle for the dial. Let's mark position 0 with a tick in a different color. And then perhaps let's do like a pointer like a clock arm for the current position of the dial. That could work. Great. So now let me open a color scheme that I like, just to copy a couple of colors from there. What do I need? Let's do clear background. Clear background. Let's do the dial in this. I don't know. I suck at colors. I will welcome any color suggestions you might have. And now let's do the pointer, not the pointer, the tick for this. So this is actually, sure, this is the dial. I'm thinking this is white. I should give these the names of the colors. This is magenta, roughly. What did I copy? I think I copied the black. And now I'll need one more color, I think, at least. Let's copy the purple. And then if it sucks, if the colors suck, we can fix them later. All right. White, magenta, black, and purple. Let's have a light background. Now, let's limit the FPS. No, I don't need to do that. Okay, let me think for a second. What do we need? We need the dial. We need to read the input, and then for each turn, we need to move the pointer. Right? That's what we want to do. Yeah, that sounds about right. So let's do the following. Let me create a function that animates the pointer. And this function animates the pointer, and this will essentially draw the pointer moving, or draw the frames of the pointer moving. So I want this function to draw the successive frames of the pointer in the starting position, then slightly to the left or slightly to the right, and then ever so slightly moving around. And we'll do this for a frame, for each frame, and we'll turn this into a generator so that I can interleave the frames with updating the screen. Because Pygame is keeping track of my frame rate, and this will draw a frame, so I want to be able to do both interleaved. I hope this makes sense. So let's do the starting point and the end point. This is what my function needs. And now in here we just need to draw the full frame. So that's going to be filling the screen with, and this is not going to be very smart. We're going to redraw the whole thing each time. So we fill the screen with white. We draw a circle, pygame.draw.circle, I think. No, I don't know the order of the arguments, so I need to open the Pygame docs. Draw circle. Let me zoom in. So to draw a circle, I need the surface, which is going to be the screen, the color, the center position, and the radius of the circle. Sorry, so let's copy this. Surface. All right, so the surface goes first, which is the screen. The color is going to be, let's do the magenta. This is a bad idea. Let's do black. Let's do magenta. Then the center is going to be the center of the screen, so that's width, height divided by 2. And then the radius, let's do close to filling the screen. So let's do 2/5 of the width. This should be nice. Now we close this. All right, okay, so then in the beginning, let's see what this looks like. So I'm going to animate my pointer, and I'm going to update my screen. Pygame.display.flip, and this should show just the circle on the screen. Nope, it doesn't, because I forgot I need to pass this here. All right, so the dial looks terrible, but this is what we have. I don't think magenta is going to be a good idea. I need someone to suggest a better color for the circle, for the dial. So we can close this. All right. So now we need this to draw the frames, and the start and end, or let's do the start and the move. Okay, and then this function takes care of figuring out where I'm going. All right, so now we need to take the input. Actually, I can copy this from my solution. We need the rotations. We need to parse them. So we need this. Let's paste it here. Okay, this gives me my rotations. And now what we want to do is get the first rotation in. So my starting position is going to be 50, sorry. My starting position is 50, and now in the beginning I want to give it the position and just the first rotation. So obviously I will need some kind of loop to go through all of the rotations, but first I want to make sure I'm able to animate a single rotation. So I want to be able to do this. Maybe this should go in the beginning. All right, and now how does this function work? Okay. So the direction is -1 if the movement is negative. Otherwise, it's positive. I'm pretty sure I'll need to check the direction. So I'll extract it now. And now what I need is, I need to draw as many frames as there are ticks. So for tick in range of 1 move plus 1. Right, nice. So now, no, this works. Okay, this works. I can just do the absolute of the move. So this is the magnitude of the movement, and this will represent the time passing. Yeah, exactly. So this represents the time passing. Now what I need to figure out is, because I'm in a circle, I will need to use angles to determine what are the positions of my pointer. So how do I take this? All right, I see. So I started at start, and my current position, I'm mid-movement. My current position is given by the number of ticks times the direction, because it might be a negative movement. So going to the left. This is my current position, and I probably need this already modulo 100. All right. Now, based off of this, I can draw the pointer. So what I do here is I'm going to call the function drawDial, which just resets the screen, which is this bit. So I'll do def drawDial. Great. And now I'll do a function to draw the pointer at this position. And one thing I like doing a lot is when I'm getting confused, or when I'm feeling overwhelmed, I just create a function. So this is getting slightly messy in my head. So what I do is, okay, let me just turn this into an auxiliary function, and when I define this function, I can ignore everything else I was doing, and I can just focus on the task I have at hand. So I want to draw the pointer in whatever position. And the pointer is a line. So let's see how Pygame draws lines. Pygame.draw line. And the line takes the surface, which is the screen, the color, the starting position, and the end. Great. So pygame.draw.line on the screen. The color, let's make it black. The starting position is the center of the screen. but the end position depends on some maths. So the end point goes here. And to calculate the end point, I need to figure out the angle. All right, so how do I do that? So the circle has 2 pi, so I'm going to need math, import math. The full circle has 360 degrees, but for these things it's best to think in terms of radians. So this is the full circle. I have 100, my dial has 100 positions, 100 ticks, and this is the angle I'm at. The angle I'm at is this, but actually in trigonometry the 0 is on the right. So let's do, where's Excalibur? What I'm saying is I have my dial, oops, I have my dial and the 0 is over here. But it's actually in the advent of code. Oh, actually on advent of code it can be wherever I want. So to make my life easier, we can just say that the 0 is on the right. And then if we don't like it, we can just rotate everything a bit. Great, so this is my angle. Now what I need is the offset in terms of x and y for the endpoints. Okay, let's see, what time is it? I think we're going to get these to rotate. Maybe not the full thing, but definitely the rotation. All right, so the offset for x is going to be, I was thinking for a second because I have a maths background, so hopefully I don't swap the two. So we do cosine and sine respectively for x and y, but this needs to be scaled by the radius, and the radius of the circle is a constant we're defining here. Width, height, radius. I said it was 2/5 of the size. So radius was here. That's going to be radius times this, radius times this. So the end point is really the center plus the offsets. Offset of y. Okay, so this should draw a pointer. Okay, so now we can test this. Let's draw a dial and now draw pointer at 0. And it should draw a pointer pointing to the right. It does, but it's very thin, so let's make it slightly thicker. Let's do width equals 5. Let's see what this looks like. Let's rerun. All right, now you can see it. It's not looking great, but you can see it. Okay, let's test with a different angle. So pointing up should be 75. Wait, should it be 75? No, it's 25. Wrong window. Where's my code? Where's my terminal? Where did my terminal go? Did I close it? Yes, I did. Apologies. Give me a second. All right, UV run. No. Where's my code? Yes. cd day 1 UV run dial.py. All right, now it's pointing down because the directions are also flipped in maths. Maths likes to do things the other way. So minus 25 should point up. All right, now for the animation, finally. Now we know how to draw the pointer at each position. So we draw the dial, to reset the whole screen. We draw the pointer and then we yield. And this is to give Pygame the opportunity. Actually, I'm thinking, do I need to make this so hard? Yeah, to update the screen. I mean, you could cobble something together in a slightly different way, but I think this will look nice. So give Pygame the opportunity to update the screen. And this yields. And when we're done, when we get to this point, that's because we animated the pointer for this movement, and we get a new movement to animate. So we restart the animate pointer function. Great, so what does this look like? Let's see, animate pointer. So let's start at 50, and let's do the following. So this goes over the rotations. Ah, I see. Okay, nice. So now we need to keep track of whether we're animating or not. So the current animation is none. And so now what you do is, if the current animation is none, you need to start a new one. So you grab a rotation. This is where you iterate over the rotations. Let's just pick one for now. You grab the rotation, and now you set the current animation to the function animate pointer, starting at the current position and with this movement. And now if there is or rather at this point you always know you have an animation. So what you can do is you can get the next frame of the current animation. So this is using generators. You can get the next frame of the current animation, you update the screen. And what you need to do next is you need to check if the animation is done. So if you get a stop iteration, it's because the animation is done. And for now, let's just break. So let's animate only one movement and then we break. And this is going to run super fast because Pygame is fast. So what we need to do is also keep the FPS in check. So let me set the FPS to 60, I don't know, let's see. And now at the bottom, we use a clock, which is Pygame's way of keeping track of FPS. And here you do a tick. I think this is the way you do it. Now let's run it. I'm slightly nervous. Will it run? Nope. Oh, the tick, sorry, my bad. The FPS goes here. All right, it was super fast, so let's slow it down artificially. Let's make it 3 times slower. And you can see, could you see it? Or it's still pretty fast. Let me make it slower. And now you can see the dial going and turning. Now it would be lovely if I could get Pygame to open the window directly on the screen instead of in the different screen I'm working on. Let's see if I can make this happen. Displays. Can I make this one my main display? I'm going to mess up everything, but it will be worth it because I'm going to save so much time in moving things around. Alright, scream if you can no longer see the correct screen. If you run dial.py. Yes, okay, this is much better because it opens in the correct place. Awesome. Now, I also lost the chat, so give me a second. Where is the chat? This is Excalibur, I might need it later, and this is the chat. Alright. Okay, it's working. Let's see. Time check. It's almost 6 p.m. my time. Alright, so I'll do the following. I'll take this. I'll mark it as... See, this creates an animation for day 1 of Advent of Code. and let's say that it is unfinished. And let me add this to GitHub. So let me commit this. So let's add solution.py and dial.py. All right, now we commit. Right, okay, sure. So let's commit. No? Okay, so then I commit from the terminal. Git commit, update solution. We push. So this is online, you can play around with it. What's the git remote origin get URL, or what's the order of these? Not super helpful, but I can tweak this. I'll paste the link in the chat in case anyone wants to play around with the code. Let's do, this goes here. All right. All right, and the reason I'm stopping for now is, even though we're actually very close to getting the... No, come on, let's do the going from one rotation to the other. So this is always getting the same one. What I can do is get the rotations iterator. So I'm turning my list of rotations. No, sorry, that's stupid. That's too complicated. So the current rotation index is 0. So we get the current rotation index, and then we set it to the next one. Plus equals 1. And if this is none, and if the current rotation index is too large, it's because we're done. We break. Otherwise, we grab this one, we go through the animations, and in here, instead of stopping entirely, what you do is you set the current animation to none, if the animation was finished. Let's run this. No, wrong command, uv run dial.py. So this should run twice going right, so this is more or less where it ended. Wait, it restarted? Oh, of course it restarted, it's because I'm silly. So what you need to do is also update your position, right? That's the whole point. So when you're done, you can say that your position plus equals the, what's the rotation, and then you also make sure you stay within the dial. All right, so now it should turn without resetting. So it goes right, now it should go right again. There was a brief pause, I'm not sure if you can see it, and now it should start going left, because my third input was a left rotation. All right, so now it goes right and left. What do I need to do? Add a counter that checks whenever it crosses 0, and add a visual cue for the 0. This is pretty cool, I think, for, was it half an hour of work, I think, or 25 minutes? And now let's update the code. Visualization. All right, everyone, we'll end the stream here, because now I have to go and do a private session on taking a look at the solution, not the dial visualization, and dissect different ways of solving this. It's for a private event, which is actually, I think, in the title of this stream. But yeah, I need to go there. So it was a pleasure solving day 1 with you folks and working on this visualization. The link is in the chat, or you just go to github.com/my name, which is a mouthful, Rodrigo Girão Serrão /AOC. No, Advent of Code spelled out. And it lives here within 2025. I'll be back tomorrow at 5 p.m. UTC again. And yeah, feel free to reach out to me if you have any questions or comments. Bye folks, and thanks for watching.